G'day and welcome to another Visions of Chaos tutorial. This tutorial is going to give examples of local vibe coding with Hermes using the Qwen 3.627b model in Llama CPP. So to start Hermes, start Visions of Chaos, Mode, Machine Learning, Text Generation, Llama CPP. Make sure you have the Qwen 3.627b model selected and make sure you've got Start Hermes CLI with Llama CPP checked. And then click Start. And once you see this screen come up, you are good to go. Okay, as I've shown in the other tutorials, this is the basic template that we are going to use. The first line goal instructs Hermes to work harder on the problem, and that usually gives a better result. The second line is telling it what sort of app we want coded, and so I choose a JavaScript app because it builds it into a single HTML that we can just double click and have a look at here easily. And then the next line is what you want the app to do. We'll come back to that in a second. And this next line tells Hermes to search the web and do some research itself. You can sometimes find example source code out there and extra information on what the task is, and so that can help it get a better result. And this next line to write a fully detailed implementation plan before starting makes the model create a full plan before even starting to code, and so it creates its own plan of the steps it needs to do to fulfill the request. And I've found that this helps with a better result in the end. And this next line is telling it to follow the plan exactly when implementing the actual code and test and verify each part of the plan as you go. That just makes sure it definitely follows its own plan and doesn't stray off track too much. And this other line here, you can use the vision tool to visually verify outputs. Hermes has a vision tool that it will actually look at the app running and see if there's any problems with it. And I always add this last line to add debug stats, because if something crashes in the app, copying out an exact error message is a lot more helpful for the model to find the problem. So now let's have a look at the line describing what we want. For this example, I thought we could try to vibe code the board game Battleship. I've not tried this before, so we can see how it works out and any bugs that arise from trying it. Okay, so this is the prompt I'm going to use. It should be the board game Battleship, human versus AI. The AI should not cheat in any way, but should use any known algorithms to improve its strategy. Okay, so to get the AI to start coding, we just copy paste this prompt into Hermes and press enter. And you'll see it does some thinking, it does some web searches. Okay, so it's currently doing some more research. And so it's now going to write the plan just like we requested it to. And it said it's written the plan now, so let's have a look at that. I have my Visions of Chaos under the VOC folder. And so Hermes outputs its files under VOC, Machine Learning, Llama CPP, Hermes. So here's the plan here. We can have a look at that. And you see it's written a fairly detailed plan for itself, covering possible things that are required. So once it has that, it then continues on doing the actual coding. We'll just wait for this to finish and then we'll have a look at the code. Okay, so that's finished now after 27 minutes. Now it's got some suggestions here that we could follow. Add ship placement by clicking individual ships in the dock, not sure what that means. Add difficulty levels, sound effects. It's good as is. Let's, for now, we'll do it's good as is and test it out. So in the end, that was 27 minutes. And most of that time was itself checking and making fixes to bugs it found along the way. Like, for example, if we stop somewhere along here, it was testing various clicks. And so it can load the board itself, check things, check the game mechanics, tweak things. That's all hands-free. You just start it off, and Hermes has got the various agents, skills, and tools, and it launches them as need be. And in the end, it says it's got the game ready for us. So let's have a look. Okay, here we go. Place your ships, click on your board or press R to rotate. Okay. Right, let's test rotate. Well, that's good. Can't place them on top of each other. Put one there. And our little destroyer will go there. All ships placed. Click Start Game to begin. Okay, let's go. Your turn. Looks like we got a hit first up, which is good. Whoop. Okay, I always found that a good strategy with Battleship is if you start diagonal lines and you then skip a line and come down, because this means that no ship of one or longer can survive from being found. And the AI seems to be doing the same method, but it randomizes around a bit because, yeah, I suppose it does just come down to random luck. Oh, got one there. He's hiding away up here. So to me, this seems like it's working fine. All of that self-checking really helped. Well, got his little one, that's good. So what do we got? There was a 4 and a 3. So there's a 3 and a 5 left. Yep, got to be up here then. And he beat me. I wasn't even watching. I was concentrating on my side. Okay, so there you go. That's not bad at all. That was one prompt. No bugs that I can see. Okay, so now let's go back to here and let's ask it to add some sound effects. I was hoping that there'd be some critical errors or bugs that we had to fix, but it did such a good job. Let's just go for some sound. So, okay. That all worked great. Can you now add sound effects for, we'll just say the game and let it decide what parts it wants to do. Okay, we'll let that go. And I'll be back once that's finished. Okay, so it looks like it's added those sound effects now, so let's see how it went. Again, it did a lot of its own self-checking here to make sure it was all working as intended. Okay. Sound is on. Okay, let's see. Oh, yep. Okay, let's start going. Right, one more 3 that it's hiding, same as me. Oh, got it. Okay, so those sounds are fairly basic, except still that's not bad at all. I was hoping to have a more troublesome round at that, and so I could show some more prompting for fixes, but that does really good. The Quen model is definitely the best model right now I found for local vibe coding. Okay, so I'm now going to show a few more examples of what I've been doing the last week or so. First of all, a 3D dungeon crawler. This is a full first-person 3D dungeon crawler. There's multiple levels. You can move around. You've got the mini-map here, enemies, and when they attack, you can go through a attack round. I can see here there's one coming up behind me, which is a green slime. There are also gear to pick up. Like here, the sandals give me a +1 to my defense, and so you just click there, it goes up into your inventory. Comes another rat. Okay, so there I've got some iron braces. We can equip those, and dragon scales. Leather boots, which have a +2 defense, which is better than our sandals of +1, so we'll equip those. These also give a better score, so we'll take those. And now we'll go down a level. And so this game has got 10 levels in total, different themes, different enemies. You can keep going down or search around for more gear. This game, as far as the working components of it, was pretty simple. It was just a lot of extra tweaks for things like the inventory and the stats and the graphics. So if you like these older dungeon crawler games, give this one a go. Next up is a texture generator, a node-based system. This was all one prompt, except for the examples drop down that had a second prompt because I wanted to try and make a few examples to show the way it worked. But if you've used any other node-based system like Comfy UI, you take the output of one thing, it goes into the next. You can blend them. As you change the sliders here, the image changes. And there's all various, the usual multiply, mix, etc. So some examples: cellular noise texture, organic membrane, wood grain, marble veins. So that's not too bad for a single prompt. I'm sure if you're more into these types of systems, you could play around with that a lot more. Next up, a periodic table of the elements. Single prompt. It has a kind of layout, and if you click on any of them, it gives you a quick overview of protons, neutrons, electron counts. It's quite nice. Next up is evolved creatures. This is based by creating creatures from spheres that are joined with springs that move at different rates. And once you start, those springs and the spheres moving, get them all to crawl around. And so the way that this works is each generation, the creatures that crawl the furthest breed and replicate to make the next generation. And so you'll see now that as it goes along, they are all moving a lot faster now. And this tends to make these worm-like creatures as the best, fastest movers. And so if we zoom out now, you see they're really moving instead of that initial blob, which was just, if we hit the reset and start again, the first cluster sort of just wobbles around. Okay, and so in order to avoid those snake-like results, I asked the AI to make sure that each sphere was joined to at least two other spheres. And so this means you can't get that single chain of sphere link, sphere link, sphere link, etc. Okay, so what that does now is the creatures all are more clumped up now. Now what we can do is just speed up the evolution. Okay, so we are getting a few that are moving faster now. There they go, crawling off. So this shows how the AI can code its own full AI system evolution, the neural networks in the back end controlling all of these and how they move and work, and it can breed them and mutate them. So I was pretty impressed with this one. This also was fairly like basic as far as the prompts go. I just gave it a fairly vague prompt describing how I'd like the creatures to be made from like nodes and links and springs, and it pretty much did the rest. Okay, so next up I tried a 2D version, a simpler, and so this has got your same sort of species made from links and springs. And with this one, it's based on the distance they move across the screen. The way it works now is it's constantly flicking towards the fastest moving one, so it's a bit hard to see what's going on. But if we really let that go for a while, and you can see the generations here. And the best is slowly going up every few generations. So now if we slow that down, that's our new current best. Next up is Carl Sims Genetic Art. Carl Sims was someone who got me into genetic art to start with, and I've got various modes in Visions of Chaos. So I asked the AI to create me a version of the Carl Sims expression trees, and it handled that fine itself. So you can like click various things, evolve. It takes those formulas represented as a binary expression tree, splits them, combines them to do breeding. And so as you go along, you can get similar patterns. Just try something a bit different like that one and that one, bit of that. So I noticed that these results, they had a lot of these sharp edges. So I asked the AI, can it not use the mathematical functions that cause those? Which are things like, if we look down here, tan does that a lot. And so any formula that's got a tan in it will lead to these sharp edges. So the AI added this smooth functions only. And now, if we reset, there are none of those harsh edges. It's all the much smoother functions like sine and cos that don't cause those. Let's see, I'll just pick some of the more, let's see how complicated it can get. So that's another one it handled itself. That was pretty much one prompt, which it then went out and did some web research about the Carl Sims work and coded this up. The next one is the neat genetic art. If you've been into genetic art for a while, you might remember a site called PicBreeder, which allowed different people to come in and rate various pictures, and then those would be evolved further. That site is now gone, but that used this same process, this neat, which is neuroevolution of augmenting topologies. So this uses simple little neural network graphs to generate the pictures. And this is also like the Carl Sims one. You choose one or more to evolve and it mixes them and breeds them further. This one creates more complex results. So, as someone who spent a lot of time doing similar things with genetic art and the binary expression trees and stuff at the back end, having Hermes code this up in minutes is just mind blowing. Okay. And finally, a node based sound synthesizer. Make some nice sounds. You can add your various sound components in. You can randomize the settings. Search will do new random setups. I mean, they're not always good, but you can always play with those. Presets, the standard. And some multi-layered stuff. It'll handle the layers itself and combine it, so you get some really nice So those are some more examples of things that I've just been playing with lately. Okay, so for the final part of this tutorial, let's have a look at modifying a app it wrote that isn't as perfect the first time. For this one, I asked it to program the game Angry Birds. The prompt was it should be a clone of the game Angry Birds, match the visuals, sounds, and gameplay as closely as possible to the original game. And that took about half an hour. And let's have a look at that. So, okay, the first problem I see is the pig structures just collapse instantly. Oh, but it's nice. You can pull the bird back. It's got that guiding. Okay, and the bird doesn't bounce off the structure, it just goes straight through it. So actually, while that's at that point, let's just start up Hermes again. I'll copy the path to that so we can tell it which file we want it to edit. Just in case it makes a huge mistake or makes it much worse, we'll just make a copy as a backup. Okay, so once Hermes is back up, we give it the path to the app, and let's say, I noticed these bugs. 1, the bird being fired goes straight through any pigs and structures rather than bouncing off them. And 2, the initial pig structures collapse immediately before being hit. And you'll see here that because it's a file we have asked it to edit, rather than continuing on from the initial prompt, Hermes has to read in the file and read the code itself and understand what's happening. And so it does a code review and then looks to fix the problems that we reported. Okay, so it took 8 minutes and 37 seconds. Let's just have a look, see how it went. The structure is still unstable, and the bird still goes straight through everything. Okay. The same problems still exist. The fired birds go straight through the structures and pigs. The structures are unstable and collapse as soon as the level starts. Okay, let's give it another round and see if it can find those issues. Okay, so another 4 minutes and it now says all patches confirmed on disk. Go ahead and refresh. I'll wait for the results. Okay, let's see now. Okay, the structure is now remaining and not jumping all over the place. Let's see how the bird handles. Okay, the bird is still going straight through all structures. This is an interesting one. Okay, let's write those up before we forget. So this is more bugs. The fired bird still travels straight through any structure. On level 2, there are parts of the structure floating in the air rather than sitting on the parts under them, which we can see here. That should have all settled on the structure when the level began. Okay, off we go again. Okay, so it's done another round. Let's see how it's patched up those issues. Okay, the structure looks good. Let's see what the bird does now. Still goes straight through. This is nicer now. The structures are all sitting on top of each other. So in theory, if I shoot the bird through here, that should all drop. But we shall see. Yeah, no. Okay. So back again. Okay. Still go through the structures. Reword this. Parts of the structure sitting above another part remain floating when the part they are sitting on is destroyed. Hopefully that gets the point across. Let's go. Okay, that one is now finished. That took a long time. It found a lot of issues, it rewrote things, but it's thoroughly tested now and it says it's all been verified. So Well, let's see how verified it is. And let's see if this is any good now. Okay. Still looks like it's going straight through. And they do drop though. Yeah, that one failed. You'll actually notice that at the end here, I got it to test up to level 5 because it tested 1 and 2 and it said, should I also do 3, 4 and 5? And I said yes, but obviously it didn't really detect that this happened. And for some reason, some of them are sort of, bloody hell, some of them are halfway translucent. Okay, I think with that one, I'm going to leave it here. I've spent hours now. For your homework, if you've got this far and are interested in doing some Hermes and vibe coding yourself, see if you can get a Angry Birds working more stable than this one that I got to. Otherwise, I hope you have enjoyed watching this and it's inspired you to try some of your own vibe coding. Thanks for watching.